Okay, so digit and coin problems. Okay, so Roman numeral 1, we're going to do some vocabulary. And the first word is you got to know what the word digits means. So let's say that you've got the number 26. So for the number 26, its digits are the 2 and the 6. So it has 2 digits to it. So that's what digits means. Now, in terms of what the digits signify, in 26, it's not really a 2 and a 6. The 2 is in what we call the tens place of the number, and the 6 is in what we call the ones place of the number. And we're going to go back to that because in order to do a digit problem, you have to know which place things are in. Okay, so second term, it's going to ask you to write a number as a sum. Write a number as a sum. So if we take the number 26, to write it as the sum, you're going to take the 2, and since it's in the tens place, you multiply by 10, plus the 6, which is in the ones place, so you multiply by the 1. So that's writing as a sum, and basically writing as a sum means it has the same value, so it's still 26, but a different form. It's a different way of writing 26. So 2 times 10 is 20, plus 6 is 26. It's still 26, it just looks different. It's in a different format. Okay, they're also going to ask you to reverse digits when working on a problem. So for example, if you take the number 32 and they ask you to reverse the digits, you're going to get the number 23. So you just switch the 3 and the 2. Now, as far as the value of the number, when you switch the digits, 32 and 23 are not the same thing. Think of them as dollars. $32 and $23 are worth different amounts. So when you express it as a sum, the sum's going to be different. For the 32, it's going to be 3 times 10 because it's in the tens place, plus 2 times 1 because that's in the ones place. And that is another way of writing 32. In terms of the 23, it's going to be 2 times the tens place, plus 3 times the ones place. So they do get different values when you reverse the digits. Okay, so we're going to do an example, and we're going to write this example out today. So the first sentence says, the sum of the digits is 10. The sum of the digits is 10. Okay, and then if the digits are reversed, the new number is 36 less than the original number. If the digits are reversed, the new number is 36 less than the original number. Okay, so your goal is to find the original number. Okay, so let's say that the original number was X for the first digit, Y for the second. And then that would mean that the reverse number is Y in the tens place, X in the ones place. Okay, so let's look at the question. It says the sum of the digits is 10. Well, we know how to do this. I have to give you the digits. This is the original number right here, X and Y. So X is the tens digit and Y is the ones digit. That's what we're trying to find. Okay, so this says the sum means add, of the digits, which the digits are X and Y, is means equals 10. So that's your first equation. X plus Y, the sum of the digits, is equals 10. Okay, so now if the digits are reversed, the new number is 36 less than the original number. Now 36 isn't the new number. 36 is the value. It's a value judgment. So when you get to being how much it's different or how much it's the same, we're talking the value of the number. So you can't just put the X and the Y together. You've got to come up with a value expression like what we did here. 26 is 2 times 10 plus 6. So this says if the digits are reversed, the new number. So the new number has a Y in the tens and an X in the 1. So you're going to go Y times 10 plus X times 1. That's the new number. Is equals 36 less than the original number. So I'm going to take the original number minus 36. Well, in the original number, X was in the tens. So X times 10 plus Y times 1, that is your original number. And the new one is 36 less than that. And that is those are your two equations for this. And then, of course, you would use substitution method or linear combination method to solve, and you'd end up with X equals 7 and Y equals 3, and then you have to put them together because the question was what was the original number? So the original number would be 73. All right, so that's your basic approach to a digit problem, is you have to know the tens digit and the ones digit. Okay, Roman numeral 2, coin problems. Basically, for a coin problem, it's actually a mixture problem. So the same basic approach on a mixture problem will work on a coin problem, but there are a few differences. One of them is that you have to know how to express coins as dollars. So let's go through that. You have a nickel, which is $0.05. A dime is $0.10. A quarter is $0.25. And every once in a while they throw in a $0.50, which would be $0.50. So most of the time when they're talking about nickels, dimes, quarters, and $0.50, those you're going to use in the equations for value in dollars. All right, so let's do an example. Okay, example, a collection of nickels and dimes, a collection of nickels and dimes is worth $3.95. A collection of nickels and dimes is worth $3.95. There are 50 coins. Find the number of nickels and dimes. Okay, this is a mixture problem because you've mixed up nickels and dimes. You have 50 of them. We don't know how many of each, but we do know how much they're worth. Those 50 coins are worth this. So we've got two totals and we're trying to pull out how many nickels and how many dimes there are. So remember, in a mixture problem, you're going to have a counting equation, which is sum x plus sum y equals a total number of items. And then you have a calculation equation, typically money. So you're going to have some amount of money times x plus some amount of money times y equals a total amount of money. In this problem, it's pretty easiest to find the totals. The total number of coins is 50. And the total amount of dollars, or total dollars, is $3.95. So you actually already have your two totals pretty much stated. So here we go. Let's say N is the number of nickels and D is the number of dimes. So basic counting equation, there's 50 coins. So N number of nickels plus D number of dimes has to equal 50 coins altogether. That's your counting equation. Now we're going to do the money equation. The money equation is amount of money for times each nickel. Well, a nickel is $0.05. So $0.05 times N is how much the nickels are worth in dollars. For dimes, it's $0.10 times D. That'll give you the amount of money in dimes. And that equals $3.95. And those are your two equations. Now, for this style of an equation, probably linear combination would be the best. So if you wanted to eliminate the n's, you would need this one to be a negative 0.05. So if you multiply all three of those by negative 0.05, you get negative 0.05n minus 0.05d equals negative $2.50. And then when you add those up, the nickels go away. And you get 0.05D equals $1.45. And then, of course, I'm just going to put ... because you know how to solve the rest of it. And you end up with 29 dimes and 21 nickels. On this kind of a question, you should get a whole number for how many dimes, because you can't have 28.5 dimes. You either have 28 dimes or 29 dimes, but you can't have a decimal. So hopefully you get whole numbers. All right, that is the end of the notes. Are there any questions about the coin problems or the digit problems?